Later I will post in the group, WhatsApp group, the attendance list untuk 4 weeks before. So ramai yang tak ada ni. Can we start class? Boleh saya start?
Boleh, Doktor.
Boleh Yang lain just tengoklah Yang tak boleh buka video, it's okay. We'll start it. So today will be Biomechanics of Human Skeletal Articulation. Skeletal tu maksud dia dalam bahasa Melayu tulang lah. Okay, tulang Last few weeks before Raya, we have learned about bone growth and development. Do you still remember how many types of bone do we have? Boleh siapa-siapa share dengan saya? How many types of bone? Okay, main type we main category we have 2. What is the main category of the bone? Cancellous bone. And the other one will be lupa dah. Buka balik kau tahu, buka balik. Appendicular, okay. That's the sub of the type, okay. But we have the main type of the bone. So spongy bone, and we have another one. There are two main types or two main category. Dia ada satu spongy or cancellous bone, trabecular bone. The solid bone, compact bone. Okay. So we have compact bone and also we have spongy bone. And when we want to divide it into several types, that's flat bone we have over there, long bone, short bone. So remember, class? And don't forget also we have a lot of bone injury. There are a lot of different type of bone injury. So you need to know about that. So today we'll move to skeletal articulation. Meaning that apa maksud dia tulang yang ada dalam badan kita. I'll try to make it as simpler as I can. So okay, there are a classification of joint, or there will be a different type of joint. Mainly joint ni, we have 3 main joint. Remember, 3 main joints. 3 ada 3 main joint. The first one is synarthrosis, or we call it immovable. So that is the first joint, type of joint. The second one is amphiarthrosis, ataupun slightly movable joint, and the third one will be diarthrosis, or we call it synovial, ataupun freely movable joint. So there are 3 type of joint. First is immovable joint, or in scientific terms we call it synarthrosis. And then the second type of joint we have slightly movable joint, amphiarthrosis, and the last one will be freely movable joint, or you can call it diarthrosis or synovial joint. When we talk about synovial joint, we always discuss on articular cartilage. What is articular cartilage? It is a protective layer of white connective tissue covering the bone surface. Dekat lutut kita, at our knee joint also, we have the protective layer, the white color tissue that cover the bone. So we call it articular cartilage, the white protective layer. Ingat Endo. So there are a few more characteristics of the freely movable joint. You can read it, but I want to show you the example of freely movable joint. So it can also be divided into a few examples: gliding joint, hinge joint, pivot joint, condyloid joint, saddle joint, ball and socket joint. So all this joint is refer to freely movable joint. Okay, yang nombor 3 tadi ya. Okay, contoh dia kita tengok sama-sama. Okay, the first picture. Ya, you all pun tak nampak saya kan. Okay, so this is the first picture. Okay, a ball and socket joint. That is the example of ball and socket joint. And then we have B. Okay, B over here is condyloid joint. Hinge joint. Hinge macam pintu dekat elbow. Dekat knee is hinge joint. And we have gliding joint, pivot joint, and also saddle joint. So there are a few examples that you need to know for each joint. Okay, so gliding joint, pivot joint, and also this is hinge joint. The third figure is hinge joint. So make sure you know the difference between each joint, because we have a lot type of joint. Gliding. This is refer to the third joint, synovial joint or diatrosis joint, or we can call it as freely movable joint. Okay. Okay, so far ada 3. Saya ulang balik. We have 3 main joint. First one is apa? First one. Apa?
Immovable.
Immovable joint. Second one is, okay, diatrosis or synarthrosis. Okay. The first one is immovable joint. Second one is slightly movable joint. The third one should be freely movable joint. If you cannot remember the scientific term, you can also state these 3 types: immovable, slightly movable, and freely movable joint. But when I ask you, can you give a few examples of freely movable joint? So this is the answer: gliding joint, pivot joint, hinge joint, condyloid joint, saddle and socket joint. So there are a few examples of freely movable joint. Okay, kita tengok lagi. What are the function of articular cartilage? I told you just now, articular cartilage is a white connective tissue that cover the bone surface. Okay, tissue color putih tu, bila kita buat operations, then we cut our skin, then we can see the white connective tissue that cover the bone. That is articular cartilage. So what is the function of articular cartilage? It spread the loads over a wide area, so reducing contact stress. Somehow, articular cartilage also provides a protective lubrications that minimize friction. Okay, so this is the main function of articular cartilage: reducing contact stress and also provide lubrication to minimize friction and mechanical wear. Ingat And we have articular fibrocartilage. So it is within the articular cartilage. Sama juga, lebih kurang. So the function of articular fibrocartilage, it's almost the same thing: distribute loads and then absorbing shock at the joint, protecting the joint periphery. So dia punya parameter dia akan protect, and then lubricating the joint. So there are a few function of articular fibrocartilage. There are 2 different things here. The first one just now is articular cartilage. Now we talk about articular fibrocartilage. Then another terms, we have tendons and we have ligaments. Basically, in tests or in final exam, it will ask you how to differentiate between tendons and ligament. Can you differentiate between tendons and ligament? What is tendon? What is ligaments? Tendon connect muscle to bone, but ligament connect bone to bone. Okay, ingat tendon tu kalau ada urat ke apa ke yang connect muscle to bone, that is tendon. But when we have something that connect bone to bone, that is ligament. Okay, different Tendon connect muscle to bone, ligament connect bone to bone. Okay, before I go further, let's just try one example, calculation examples. The forearm and bicep support 2 kilogram load at point A. Okay, if at point C, we can assume as pin support, so point C is pin support, determine the force acting on the bicep and also at joint C. So where is the bicep? Bicep yang color merah tu lah, yang ada muscle tu. So that is bicep. So the question wants us to find the force in bicep, meaning that force from B to D. Okay, B to D, yeah. And also the question wants us to find the force at joint C. The keyword here, okay, you can see that it states pin support at point C, pin support. So pin support, we will have forces in X and also Y. Itu kena ingat ni. This is what we learn in engineering mechanics. Okay, if we have pin support, for examples. Okay. This is roller. This is pin support. Okay, pin support. If roller, if you convert it into free body diagram, we will only have Fy. But if pin support, we will have Fy and also Fx. Why? Sebab apa jadi macam ni? Why this happen? Roller, okay, if I have a roller over here, this beam can move in X direction. Okay, it can move in X direction because it is a roller over here. It cannot move in vertical directions because this roller prevent the beam from moving in vertical directions. Because that prevention of the roller, then we have Fy. Sebab dia tak boleh gerak pada Y, so we have Fy. It can move in X, so we don't have any X over here. But for fixed support or pin support, for pin support, it pin here at the beam, so this beam cannot move in X and also cannot move in Y. So that is why we have Fx and Fy, because the pin support over here prevent the beam from going in vertical and horizontal directions. Can you understand, class? Faham tak? Faham ke? Why we have Fy, why we have Fx, Fy over here? Faham ke?
Faham dah tu.
Jangan silap So roller macam lain, pin support macam lain. So there are a few conditions that you need to know. Okay, so now we want to find FBD. FBD over here. And also at pin support at point C, we have Cx and Cy. So there are three. Basically we will have three equations. One is moment equation. Second is Fx equal to 0, Fy equal to 0. So there will be three basic equation that you need to know. Because this is 2D problem, so only three equation, But when we deal with 3D, then we will have Fz equal to 0. So now, there are three unknown, FBD, FCY, CY and CX. From point C, and then we have point B, and we also have here point A. So from here, from the second figure, I can see that point C has many unknown compared to the other point. Dia ada banyak unknown yang kita tak tahu. So we have CX and CY at point C. So that's why I will choose point C as a start for my calculations, because I want to erase or to delete these two unknown. Yeah? So I will start my calculation with point C. Moment at point C equal to 0. Okay. So point C now, we just eliminate anything at point C. Point C, yeah? So my reference point is point C right now. Every forces will rotate at point C, because now we consider moment, yeah? So now the first force that we face from point C is FBD. It has the angle of 75. Cos or sine? Cos or sine? That's the other issue. I guarantee not everyone will get the correct answer. Some of you will put FBD sine 75. Some of you will put FBD cos 75. So how do we choose the right one? Macam mana, eh? We'll draw again here to make everybody clear. Okay. This is FBD. 75 degree. Okay. Almost similar, eh? Our FBD, so this is Fy. This is Fx. Okay. So Fx, Fy. Now, for this figure, I want to resolve FBD into Y directions. Into Y direction. Into Y directions. Sebab apa? Why? Because we want to write down the equation of moment. Moment is equal to force times perpendicular distance. So if you want to make a perpendicular distance, distance is 0.07. So perpendicular distance to the force should be, here should be 90 degree. So that's why we are moving FBD into the vertical axis. Eh? So how do you resolve FBD into vertical axis? From this triangle. Now I want to find Fy. If I just try cos 75 equals to, anybody? Cos 75 equals to Fx. Divide by
FBD.
Okay, good. FBD. So when I arrange back, so Fx will equals to FBD cos 75. Okay. But now I do not want this force resolved into Fx. I want FBD to be resolved into Fy. So we'll try again. Let's take sine 75. It will be Fy divided by FBD. So Fy equals to FBD sine 75. So here, Fy. So you want to resolve it into Fy. That's why we take this thing. So FBD will be sine 75. Okay, class? So why I choose sine 75 instead of choosing cos 75? Because now I want to resolve FBD into y directions. If I want to resolve into y directions, then from here you can see that Fy equals to FBD sine 75. If for other cases, if I want to resolve it into x directions, then we need to choose FBD cos 75. Okay, but now the condition is Fy. That's why we use sine 75. Okay, so moment equal to force times perpendicular distance. Distance is 0.07. Plus or minus the arrow, this arrow, FBD. Okay, this arrow or that arrow. The arrow is counterclockwise. Point C is over here. So the arrow is going up and it will rotate at point C. Counterclockwise is plus. Mostly we use counterclockwise for moment as plus. Okay, and then I have another force, the weight. So the weight is 2 kilograms. 2 times 9.81, you need to convert into Newton. And the distance should be 0.23 plus 0.07. It will be 0.3 equal to 0. The direction here, because the weight is going down, it will rotate at point C. The rotation is clockwise. Okay, going down and then rotate at point C. Clockwise will be minus. From this equation, straight away you will get FBD equals to, boleh baca kat saya jawapan tak? Berapa nilai FBD? FBD equal to berapa jawapan dia? Dalam slide pun ada tu. Tapi tak sure lah jawapan betul ke tak. 87.05 Newton. Okay. Any questions for FBD? Ada soalan tak yang korang tak faham? Kena tanya jangan simpan. Any question, class? Ada soalan tak? Nur Suraya, ada soalan?
No, doktor.
Tak ada Okay, yang lain okay Tahu macam mana nak tulis equation ni. Okay. Okay, this is the first step. So now you have solved FBD from this figure. The second question, we need to find CX and CY. So for CX, of course, summation of FX equal to 0. Okay, what do we have in X directions? We have CX. Because I assume CX going to the right hand side, meaning that CX is plus. If you assume, okay, some of you maybe will assume CX going to the left hand side. Some of you will assume CX going to the right hand side. It depends on you. That is just a directions. So if you assume CX going to the left hand side, so it will be minus over here. So it is not a mistake, but it is based on your assumption. if you draw CX going to the right hand side, then you should put plus. Okay, plus, eh? So we have CX going to the right hand side, and then we have FBD over here. So now you need to resolve FBD into X, because now we are calculating forces in X directions. So that's why when X came, so it will be FBD cos 75 degree. We want to resolve it into Y, it will be sine. We want to resolve it into X, it will be cos. Plus or minus over here?
Minus.
Confident? Minus?
Confident.
Oh, confident ni kuat. Alright, minus. Good. Sebab apa minus? Why minus? Because if you can see from the arrow of FBD, it tends to the left hand side. Eh? So left is minus lah. So equal to 0. Don't confuse ya class. Now is summation of fx. So no need to time with distance. Eh? This equation we time with distance because moment. Now is summation of forces. Only forces in that equations. So substitute FBD into that equations. Okay, this value you will get CX. Anybody, can you share me the answer for CX? CX. That one. CX. Okay, Kira. Okay, berapa nilai CX? Come on, siapa boleh cakap?
80.24.
80.24. Okay, saya nampak ada yang macam mana? Ada yang cakap 22.53?
Sila kira dulu.
Jaga-jaga. Okay, 22.53. Kira balik Newton. Okay, the last one. You want to find CY. CY in Y directions. So summation of Fy equal to 0. Okay, you have CY. Now I assume CY going down. So minus CY. If you assume CY going up, then plus. Okay. Okay, let's say, before that, let's say some of you assume CX, minus. So your final answer will be minus 22.53. Still correct, don't worry. The value is still the same. Either you assume plus or minus. The different thing is only the sign over here, minus or plus. But the value here will be the same, yeah? Plus or minus sign is just a direction, so don't worry too much. Okay. So for the third one, we have CY going down minus, and then we have FBD. Resolve it into Y, it will be plus FBD sine 75. And last one, don't forget, we have the weight over here, minus 9.81. Okay, equal to 0. Okay, so CY Try to calculate it for me. Adni cakap 64.46. How about the rest? How about the rest? 64.46. Okay. Okay. Aina also got the same answer. Anis sama ya, Anis. Anis Raihana sama ya. Okay, good. Yasin, sama Yasin? Okay, Ain Izzati pun 64.46 ya. So this is how you solve the question. First, you need to find which location has the highest unknown parameter. From here, we can see that point C has the highest unknown parameter. Ya. Ada dua unknown kat point C. So that's why we want to eliminate these two unknown by using moment equations. That is the first step. You cannot choose point B to start your moment equations. If you choose point B, in your calculation, you still have Cx and Cy. But now when we choose point C, we only have FBD, one unknown in our calculations, and we can straight away solve that unknown. So remember class, to write down the equation, the first equation that you need to write down is by choosing the most unknown location first. Then you write down the equation of moment. Lepas tu baru kita go further for the next equations. Okay ya? Boleh ke?
Boleh, Doktor.
Yeah. Okay, kita move to the next slide. So this is the solution from the books, right? So similar to our calculation just now. And then, okay, the next one. This is the famous questions always been asked in the test or in the final exams. It is like the question is like this. Can you explain briefly or can you differentiate between joint stability and also joint flexibility? There are two terms here, stability and also flexibility. So what is joint stability? It is ability of a joint to resist abnormal displacement of articulating bone. Or maybe you can write on your own words. Make sure I understand, okay, your answer. So what is joint stability? Basically, it's a ability of a joint to resist abnormal displacement. And then there are a few factors that increase joint flexibility, joint stability. So the factor is, you can see that a closely reciprocating match of the articulating bones. So all the bones should be arranged closely. There is no much gap of the bone. And then we have a strong array of ligaments, okay, and muscle tendon causing the joint. So we need the arrangement, yeah, of the ligament should be strong. And then we cannot have any muscle fatigue. Kalau ada muscle fatigue, then kita tak stable lah. If one of our muscle in our leg, for example, our left leg, for example, if we have a fatigue on our muscles, then how can we stand? Macam mana kita nak berdiri kalau ada muscle yang lesu, yang letih pada kaki kita? Macam mana kita nak berdiri straight? So that will affect our stability. And then this is joint flexibility. Another terms. What is joint flexibility? It is a description of relative range of motion, or we call it as ROM. ROM is relative range of motion or range of motion. Yeah. So ROM is range of motion at a joint in different directions. So every person will have their own ROM, range of motions. Mostly now we can see that our gymnast will have the high range of motion compared to footballers or compared to any other sports. So that is related to joint flexibility. Yeah? So that is example of range of motion that we can measure from anatomical position. Okay, so that is gymnast. Bukan Farah N, eh? Okay. Then what is the factor influence joint flexibility? Just now we learned about factors influence joint stability. Now is factors influence joint flexibility. Still absent of muscle fatigue, muscle tak boleh fatigue, and then tightness or laxity in the muscles and collagenous tissue causing a joint. So if we have tightness in muscle, so muscle tu macam dia kejang sikit, then it will affect joint flexibility. And if we have intervening bony or muscle tissue or fat at the end of joint of motion, so if you have too much fat, okay, then it will affect your ROM. Kalau ada lemak banyak, jadi that's why kita tengok when we see all the gymnasts, semua slim. If you have too much fat, then how do you get your high range of motions? So that's why all the gymnasts, you can see, semua slim, fit semua. Okay. There are a few receptors that influence extensibility of muscles. So this is just a brief for you. We have Golgi tendon organ, we have muscle spindles. So this will affect your extensibility of your muscles. Okay, saya tak go details lah yang ni. Okay, you can see some of the tests that we can use to check our muscle spindle functions. So when you knock your knee, okay, somehow it will reflectively move your leg, yeah. So this is knee jerk test. Okay. So how we increase our joint flexibility? There are a few techniques, but mostly to increase our joint flexibility, we use or we will do stretching. Kena buat stretching to increase our joint flexibility. So there are a few types of stretching. One is active stretching. The second one is passive stretching. We have other stretching, ballistic stretching, static stretching. Banyak stretching ni. So a few examples of static stretching. Just stand in one place and then you can do this type of stretching. Hamstring and then trapezius. That is the name of the muscle, yeah? Trapezius muscle. If you do that type of stretching, then it will affect your trapezius muscles and it will affect somehow the bicep muscle, hamstring muscle, quadricep muscles. So this is a few examples of static stretching. Okay. Try on your own. Find what is the example of ballistic stretching, passive stretching, and active stretching. I do not put the example of that stretching over here. Try on your own to find a few examples that relate to active, passive, and also ballistic stretching. What is the different things, different parameter between these four basic stretching? Try cari, ya. Okay, ni tak ada apa. Okay, common joint injuries and pathologies. So we have sprain, dislocation. This is related to joint. Yeah. Previous lecture we learned about bone injuries. Now it is joint injuries. Biasa ya? Bone injuries, we have green stick. We have spiral fracture. Okay, there are a lot more. Now it is joint injury. So we have sprain, dislocation, bursitis, arthritis, rheumatoid arthritis, osteoarthritis. So common type of joint injury is osteoarthritis. Common type of bone disease is osteoporosis. Jangan sama osteoarthritis, osteoporosis. So it's different name, different term, yeah. So what is osteoarthritis? Common degenerative disease of articular cartilage. So the symptom is pain, swelling, restriction of range of motion, and so on and so forth. Okay, that's it for joint. Human joint today for chapter 5. Any other question, class? Ada soalan tak? Ada soalan?
No, Doctor.
No? Betul ke tak ada soalan ni? Hari Isnin kuis ni? Sekejap, saya paste link ya untuk attendance. Nanti saya share dalam grup Sekejap. Any question that relate to quiz 1 next week or the assignment 1? Ada soalan tak? Tak ada tak ada soalan for assignment, so make sure you submit the assignment on time lah. Okay, class. If there is no more questions, then I think I'll see you again next week on Monday night. Okay? On Monday night, I will announce again what time that you need to answer that quiz. Then I will update in the group, yeah? So if there is no more question, I think I will see you again next week. Thank you very much, class. And Assalamualaikum. Have a nice weekend, yeah? Long weekend,
Salam. Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.